Hey everyone, hope you're doing well. Here's a video to go along with today's lesson. And what we did in today's lesson was we looked at object-oriented programming for the first time, officially. And so what we did was we made a new class called Vector, and we put in the basics that you're going to need to make it something that works as a vector. So, we're going to do that, and I'm going to introduce the first official assignment. So, let's get started. So, to make a new class, we need to declare it. So, I'm going to say class, and this is the vector class, and then brace, and there we go. Why do I have all of that stuff? Oh well, doesn't matter. So, now I've made a class, and typically the first thing that you do in a class is you declare what the class variables are going to be. And so if this is going to be a vector, and I'm going to say it's just a 2D vector, so it only needs to hold on to two pieces of information, basically the x and the y coordinate for that vector, right? So I'm going to make two new state variables. They're going to be doubles. That's double, like that. And I'm going to call them x and y, capitalized. There we go. So you can see that they're blue. Blue is indicating that they're a state variable, as opposed to kind of a brown color, which means that is a local variable for that function. So, after we declared our state variables, we need to make our constructor, because we want to make vectors. And so, the way we do that is it's going to be a public constructor, and we just name it exactly the same thing as the class, just like that. And then do we need to give it any parameters? Yes, we do, because we need to know what the x and the y are when we're making this vector. So I'm going to say it is a double x and a double y being received. And now we say, what do we want to do, or what do we have to do when we start or make one of these vectors? Well, we need to assign whatever those parameters are to the class variables here. So I'm going to say this x, and this is how you refer to the object's own parameters, because we haven't given this object a name yet. So this is kind of a placeholder for their name. So this x is going to equal x, and this y is going to equal y. There we go. We've assigned those two values that they passed to us when we construct it, and put it into our class variables here. Now, we've got a constructor. Next thing we want to do is we probably want to be able to print this thing out and see what it does, or what it looks like, right? So, every function has a couple special, or every class has a couple special functions. Not like Python, where you can overload pretty much everything. Here, what we have is the toString function and the equals function. And the toString function is really useful because it's kind of implicitly called whenever you try to print something to the console. You don't have to actually call it yourself and then get the string. It'll just do it on its own, as long as you call it toString. And equals, because we need to know when these things are equal, because we can't use equals the normal way. So, the toString function is going to be a public function. It's going to return a string. It's called toString, and it doesn't actually need any parameters, because we're just going to be returning this thing, or whatever the vector is. And so we're going to return, and I'm going to do some string formatting. So string.format, and here I'm going to want to display my function kind of in square brackets, so it's going to be the x coordinate and then the y coordinate. And typically you use square brackets for representing vectors. So that's going to be like this. And I need to put in a value here, so it's a floating point value, which means I need to use lowercase f. And then after that, another lowercase f with the y value. And then over here, I say what you put in those values, well, you put in this x, as well as this y, in that order. And that's it. That is our toString function. Now, it would be really nice if we could test things out and see if they're in fact working. So to do that, down here, I'm going to make the main function that we can use to run some stuff. So I'm going to say public, and public void, public static void main, string args. There we go. So there we got our main function, and in here we're going to create a vector, and then we are going to print it out to the console down here. So I'm going to say make a new vector, call it vec1, vec1, and it is a new vector. So this is how you call the constructor function. You say it's a new, and then name of the thing that you want to make, so it's a vector, and we need to give it two values, an x and a y, and we'll use 1, 2. There we go. So we got a new vector called vec1, and now let's print it out to the screen. So system.out.println and vec1. There we go. And now we should be able to run this thing. Run as, don't run configurations. Oh, that's not what I want to do. I want to run this one. Run this one. Yes. There we go. I added a new file here, so that's why it's doing this. There we go. Took a little bit of time, but that is our function printed out. Notice that it used the toString function, even though I didn't actually call it the toString function. Because toString is a special function. Alright, now we're going to do the equals function. So public, we want to return a boolean, because we want to return true or false. Are these things equal? And it's called equals. And what does it need as a parameter? It needs to have the vector that it is comparing to. There we go. And when are two vectors equal? Well, they're equal when this is equal, or their two components are equal. So I did it with an if statement in class. This time I'm actually going to do this as a one-liner. I'm just going to return, and then I'm going to do a Boolean expression here. So I'm going to return this dot x equals vec dot x. So are there two x's the same? And this dot y equals, I need double equal, vec dot y. And that's it. So this is going to be evaluated as true or false, and then I'm going to return it. And if it's true, then it's true, and if it's false, it's false. So that's one line to do what I did, and I think 3 lines in class. What else are we going to do? Alright, so let's see if this equals works. So let's vector up a new variable. There we go, new vector. Vector, and this will be 2, 1. Alright. And I want to print if these two are equal. So equals and vec2. Are they equal? Please tell me. Nope, they're not equal. And they're not supposed to be. What if I made them equal though? So 1 and 2. There. Now they're equal. True. Perfect. So, now we got the basic special functions done. Next, I want to talk a little bit about a very common type of function made in Java and why it's made. And it's called the getter and setter functions. And so what the getter and setter functions do is basically exactly what they sound like. The getter functions get a value and the setter functions set a value. Well, I could actually do both of those just by handling these parameters directly. Why do we want to use functions to do this instead? Well, there's two main reasons. Typically, you want to keep your variables very well protected. So typically, these are made as private variables. And so, often, you also want to kind of detach the ability to get the value versus setting the value. If I just handle with those directly, both getting and setting have the same permission value. But if I use a getter and a setter, I can put different permission values on both of those. So that is the first reason why you would use getter and setter functions rather than affecting these, is because you have more control over the permissions to access those variables. So we're going to make a getter function, sorry. It's going to be a public function because getting the value of something is not really harmful at all. Can't actually hurt anything but the vector. And so what it is, it's going to return the value of one of these things. So it is going to return a double. And it's going to be called getX. So this is typically how they're always named. It's always get and then what are they getting. Or in setters they're going to be, set and whatever they're setting. And it doesn't need any parameters. And what is it going to do? It's just going to return this x. That's it. That is a basic getter function. We can also make a setter function, but this is going to be a private setter function. And it's not going to return anything, and if we don't want to return anything, we do void. And it's going to set x. This does need a parameter because we need to know what we're setting x to. And so I'm just going to say this is a double value. And how do we actually make the code in here? Well, all we do is we say this x equals value. That's it. That is what a setter function looks like. Now, what we want to do is we want to add some basic mathematical functions that you typically use vectors for. Because while we do got something that is a vector, and we can check if they're equal, and we can print them out, we can't actually do any vector math with them. So that would be the next step that we need to do for here. And a very common mathematical operation that you do with vectors is you add them together. And how do you vector add? Well, you just add the components together. So I'm going to make a new public function. And what is it going to return? Well, this is going to be my adding function. It's going to return a vector. So it's going to return a vector type. And what am I going to call it? I'm going to call it add. And how do I add something? Well, I need to know what the other vector is. So vector, and then we'll just call it vec again. There we go. And now we're going to say we need to get the new x and y values. So I'm going to say new x equals this x plus, I want to say that x. Maybe I should call it that vector. Yeah, let's do that. That sounds like fun. I'm going to call it that. So this x plus that x. And new y equals this y plus that y. Oh, I didn't declare what these things are. These are doubles. Double. And now that we got our new x and a new y, we can call our constructor to make a new vector and return it. So we're going to return a new vector with the new x and the new y. There we go. So now we got an adding function. Let's see if it works. Let's add these two together. Just like that. And I should get 2, 4. There we go. Perfect. One other thing that you typically do with vectors, or would like to know about vectors, is their length. What is their magnitude? And that would require that we get the square root function, because in order to get the magnitude of a vector, you need to apply Pythagoras, right? So, let's see how we do that. It's going to be a new public function. It's going to return a double, lowercase double, and it's going to be called just length. And it doesn't need to have any parameters because we're just going to use the class parameters in order to calculate the length of this vector. And so, what do? We return, and we need to do the square root of x squared plus y squared. Well, how do you get square root? Well, you use the math library. So I'm going to say math dot square root, and I want the square root, and rather than, there isn't really a square function native to Java. Like typically you can do like that, and that's considered to be 3 squared. In most programming languages, Java doesn't do that. It does have a power function in math, but I am going to do something else, and I'm just going to multiply the number by itself in order to square it. So I'm going to do this x times this x plus this y times this y. There we go. And that is now my length function. Let's see what the length of this thing is. Because it's going to evaluate this first. It's going to give me this vector, but it's still a vector object, so I can say, rather than print the vector, I want you to print the length of that vector. And what do I get? Seems reasonable. Alright, there we go. We got a length function. So now we can add vectors, we can figure out the length of the vectors. Great. And that is about as far as I want to go with this. We looked at all the main types of functions that a class typically has. We got the string function, or the toString function that allows us to print nicely to the console. We got the equals function that we need to check whether or not two things are equal. We got getters and setters, which are common in Java quite frequently. I didn't tell you the second reason why we use these. The other reason why we use these is because setter functions often have some additional code in order to verify that what it's setting the value to is a valid thing to set it to. So that's kind of like error checking and range checking and whatnot that is done by the setter function in order to ensure that there's not any bugs or something that happens because it gets set to an invalid value. So that's the other reason why you use setter functions rather than just work with the variables directly. So then we looked at how do we make adding stuff together. So this is a function that returns the very type of object that we made here. And we take a look at the math module briefly, or at least how to access that kind of functionality. And then that's just the running code. So that is enough for us to go and take a look at the new assignment. There's only one thing that I haven't shown you, and I will discuss it when we reach it. So in this assignment, you'll be creating a new class of objects called fraction. you will have two class variables to store the numerator and denominator, and a variety of overloaded functions to support the mathematical operations with either fractions, integers, and even floating point numbers. So this is the overloaded functions thing that we haven't talked about yet. And what that means, an overloaded function in Java means a bunch of different functions that all have exactly the same name, but with different parameters. So let's take a look at my fraction example here. I'm not going to show you everything, but we're just going to take a look at the add functions. And you can see I've overloaded the add function. They all have exactly the same name, but they have different parameters. And so what this allows us to do is to have just a single way to call the function, but different code that will handle how you do that depending on what you give it. So if I want to add a fraction and a fraction, this is the code in order to do it. If I want to add a fraction and an integer, this is the code of how you do that. And if I want to add a fraction with a decimal point number, this is the code to do that. And so depending on what I pass it, it will run a different function just based off of the type that you pass it. And that's what is meant by overloaded functions, okay? So, now we can go back and read the rest of it. So, I've given a testing program that you can use to test your fraction class. You'll have to make sure that everything is named correctly in order to make this thing work. Also, I will show you how you have to add it so that it's actually accessible. And I'm still not entirely sure if it's entirely working. Anyways, so you don't have, it's not just adding it to the same folder. In fact, you shouldn't do that. What you need to do is you need to import it. So I will change this after I record this. I note that the math library is going to probably be useful here, especially once you get into simplifying your fractions as well as working with decimal points. And so I gave a link to the documentation for the math library. So 0, create the class and establish the following private class variables, the numerator and the denominator. Create a constructor class that will take in two integers and assign the first integer as a numerator and the second as the denominator. Create public getter functions for the numerator and denominator so that users can access but not change the state variables. Create public functions that will add, subtract, multiply, and divide the fraction with another fraction and return as a fraction type. The function names should be as follows. So you're going to make an adding function, subtracting, multiplying, and dividing function. Say, note, you should use your knowledge of fractions to divide fractions without actually using the division operator. You might ask, why would you want to do it that way? The reason is because of all the basic math operations, computers are the worst at division. All the other ones are actually pretty basic and can be done quickly, but if anytime you ask the computer to do a division, it actually takes a fair amount of steps. Just think back to when you were first learning division and they taught you long division. That's basically what the computer has to do. It has to do long division every time. So if you can find a way to do it without actually using division, it's going to be a lot faster. Another reason is because division is, of all the 4 basic types, also the most prone to giving errors. And that is specific for when you're working with floating points. So here, we're going to be working primarily with just integers, not as big of a deal. But with floating points, yeah, you want to avoid doing any kind of division with floating points because they're very prone to error and they will wipe out your precision very quickly. Yeah, so try to do it without actually using division. Create a toString function. We already saw how to do that. Create a toDouble function that will return the fraction as a decimal. Create an equals function that will check if they're equal. Overload your operation functions to allow them to work with integers and later on as well as decimals. Create a private simplify function that will take in a fraction as a parameter, simplify it to lowest terms, and then return it as a fraction type. 9. Use the simplify function. Ensure that all fraction operation functions simplify the result before returning it. So all the fractions that are ever used should always be in lowest terms. Create a public decimal to fraction function that will take in a double as a parameter and convert it to a fraction and return the result as a fraction. That might be something that you want to use the math library for. And then use it to create another set of overloaded operation functions that allow you to add decimals and fractions. So that is our first assignment that we're going to have. So let me show you about using this program. I'm not entirely sure about this, so you might have to play around with it. Sorry. But if you go to whatever your package is, if you're just using default package, you can probably use default package, and right click on it and go down to import, and you want to import, select general, and then file system, and then you can go browse, and you need to select the folder that your the file is in. So it's probably going to go to your downloads folder. So if you select that, and it'll have a whole bunch of stuff show up, especially for me because I got all sorts of stuff that I've downloaded over even the last year. And then down here I should have test fraction.java. So you want to select that and hit finish, and it shows up right there. So we can open it up, and this is the thing that I am going to be using in order to test your code. Get rid of that line because it's not in the fraction package, so that should fix that error. And so you can see that I create all sorts of different fraction objects, and then I got a whole bunch of if-else statements that are basically just a quality test to see if everything works, and it'll print out the results of the test down here. So I haven't tested this yet, so I really hope it works, but if I run this thing, there we go. Let's see. It tells you if you passed or failed and what test it was operating on. So if I fail in a quality test, you know, oh, something's wrong with my equals function, fraction add, integer division, decimal subtraction, etc. So in order for this to work though, you got to make sure that you're naming everything the same way that I asked. So especially the fraction object's name as well as the name of the functions themselves. Everything else doesn't matter. Yeah. So that is the first assignment. I don't expect that we're going to spend too much time on objects because we are going to revisit the more difficult aspects, or more advanced aspects, I would say, when we get into looking at the swing library and how we make GUIs. But that should be it. So have a good one, everybody, and I will see you all on Thursday. Oh, also, this new assignment will have a soft deadline of next Monday. Okay? Alright, have a good one, everybody. Bye.